So, if we're going to start by finding what f of x plus h is. We got our function given here. Our understanding about how we play with these functions is we take whatever is inside here, go back to the function as it's defined, replace the x's in that function with this piece. So we're replacing the x's with x plus h. If I replace the x's with x plus h, I get 2 times a quantity of x plus h, that substitutes in the place here, minus 5. And at this point, there's really not a whole lot extra we could do. I mean, we could distribute the 2 through, get 2x plus 2h minus 5. But then if we're looking to join like terms, we're disappointed because we can't go any further. But we've accomplished this piece of the directions. Now let's look at this difference quotient idea. So for the difference quotient, what we're trying to do is we're trying to find f of x plus h minus f of x all over h. So really the difference quotient involves 2 pieces. It involves the f of x plus h part. That's this guy. And we've already found that right here. So why don't I take that answer, bring it down here, and substitute in the place of f of x plus h in my difference quotient. So if I do that, I've got 2x plus 2h minus 5. Okay, so now that's replaced. Apparently I'm subtracting with this difference quotient what f of x is. Well, f of x, that goes back up here, right? F of x is 2x minus 5. So let's substitute that in. In the meantime, according to the difference quotient, this is all over h. So there's the setup. If I'm going to evaluate a difference quotient, it's helpful to figure out what f of x plus h is off the side so you can plug in. Now we've got everything set up. I'm going to distribute my negative through. Right, that changes my signs. I'm going to collect like terms. So notice the 2x's, right? They're disappearing here. The 5's, they're disappearing. All that stuff's going to 0. And I'm left with 2h over h. And that's what's supposed to happen on these problems. You're supposed to be left with terms on top that only have h's in them, so that you can take this h down here and divide it into all those terms on top. So I divide this h in to that h there. H's divide out, and I'm left with 2. So the difference quotient equals 2 here. So new function, same routine. Start with figuring out what f of x plus h is. We appreciate the x plus h inside here is replacing the x's back in the original function as f is defined. So we substitute in the place of these x's that x plus h, and we get x plus h as a quantity squared minus 3 times x plus h, all that plus 1. So like we discussed in the last one, might make sense to do a little distributing, expand some things out, see where that takes you. Maybe there's some terms you can put together. This x plus h as a quantity squared, remember that means x plus h times x plus h. If necessary, FOIL it out. Or remember there's that shortcut, square the first term, x squared, double the product of x and h, get 2xh, square the last term. Either way, there's the expansion on that binomial. Now, take this negative 3, distribute that through. minus 3x minus 3h, tack on the 1 at the end. Once again, if we're looking to collect like terms, we're disappointed. There's nothing to put together. However, this work will serve us well as we try to figure out what the difference quotient is. So I set up my difference quotient down here. I start with the f of x plus h part of that difference quotient. I understand that involves taking the work from up here and bringing that down, so let me transfer. Got my x squared plus my 2xh plus my h squared minus 3x minus 3h plus 1. There's that substitution. We are subtracting basically the original function, right? We're subtracting f of x. So f of x was x squared minus 3x plus 1. Make sure we group it properly because we have to distribute that negative through. That is all over h. We've got that all set up. Distribute your negative. Carry that minus through. Now we collect like terms. Notice what happens with the x squareds. Notice what happens with the 3x's. And then the constant values of the 1's go away. What remains, on top we should have some terms that only have h's in them. So notice we've got a 2xh plus h squared. Also got a minus 3h. And that's all the terms that are left over on top. This is all over h. So we know we're doing these correctly if only h terms remain on top. Now we take this h right here, we divide it into all the terms. Dividing this h into the first term, you've got 2x left. Dividing this h into the second term, we've got plus, well, there's two h's there, there's one h there divided in, so one h remains. And divide this h into the last term, we're going to have just minus 3 left. So there's our expression that represents the difference quotient.